Hello everyone, welcome to ID and Gate classes. So today we are going to discuss the questions asked in the Gate 2024 for the electrical branch from the subject signals and systems. So there were few questions that were very easy, direct formula or property based questions, and there is some tricky questions also. So we are going to solve all these questions one by one. Before starting this session, I would like to tell about the GATE 2025 and 2026 courses that we have launched. The admission is open. You can join this course and you will get the GATE online coaching, target GATE courses, GATE online test series, and the distance learning program. So we join this particular course and excel in the GATE. So GATE 2024 electrical branch, the weightage and the marks distribution, let's see. This is the technical paper, and 1 mark questions was asked 3, 2 marks questions were 4, so total 7 questions were there. That covers the 11 marks altogether. So this is the first question, which is the MCQ based. Suppose the signal yt is obtained by the time reversal of the signal x of t, that is yt is equal to x of minus t, t is from minus infinite to infinite. Which one of the following option is always true for the convolution of xt and yt? So we know that if we want to convolve the two signals, suppose we want to convolve the yt and xt. Okay, if you want to convolve yt and xt, then you can write integration from minus infinite to infinite y of tau x of t minus tau d tau. Okay, this can be the convolution integral. Now here what we are saying is that suppose the signal yt is obtained by the time reversal. So now the yt is x of minus t. Which one of the following option is always true for the convolution of xt and yt? Now this is nothing but the yt is x of minus t. So here this x of minus t, because yt is actually achieved by time reversal. So x of minus t and x of t, and this is now minus infinity to infinity, y of minus tau and x, I should write y of minus tau, or you can also write this as x of minus tau, because this yt is replaced by x of minus t. So this is x of minus tau and x of t minus tau d tau. Okay. So if you will see this signal, then it is nothing but the same integral, or you can say this is the convolution between x of minus t and x of t. And this represents the left hand side of this integration, left hand side of this equation represents correlation between the signal. Okay, correlation between the signal. And by the property of the correlation, we know that the correlation follows that the correlation is always a even symmetry. Correlation function always follows even symmetry. Always follows an even symmetry. That means when you convolve the x of minus tau or minus t with x of t, you are basically calculating the correlation between the function or between the signals, and correlation always follows the even symmetry. Hence the convolution of this xt and yt, which is nothing but the convolution of xt and x of minus t, which is the correlation, will be an even signal. Okay, very basic property based question. So when you replace this yt by x of minus t, you have to understand that this left hand side becomes the correlation, and the correlation says that it always follows the even symmetry, hence the result will be even symmetry. The next question, that is also an MCQ based. If ut is the unit step function, then the region of convergence of the Laplace transform. So if you will see this signal e to the power t square ut minus 1 and ut minus 10. So this is again a direct question. This particular part shows that the signal x of t will be bounded. Signal x of t will be limited from 1 to 10. Okay, limited from 1 to 10. ut minus 1 starts from 1 and ut minus 10, that means it will end up to 10 because there is a minus sign. So that means we can say that this is a finite duration signal. This x of t will become finite duration signal. And for finite duration signal, what is the property? ROC will be entire S-plane. ROC will be entire S-plane. Again, this is the property base. So my entire S-plane means real part of S should be greater than minus infinity and less than plus infinity. So the right answer is option. Very simple question again. Now the next question is, let x of omega be the Fourier transform of the signal. X of t is equal to e to the power minus t to the power 4 cos t minus infinity to infinity. The value of derivative of x of omega. So we have to calculate the value of derivative of x of omega. Okay, now what is the definition of x of omega? That is the Fourier transform. X of omega is integration from minus infinity to infinity x of t e to the power minus j omega t dt. Now we want to calculate the derivative of x of omega at omega equal to 0. So if first of all, if I take the differentiation, because first of all we have to take the differentiation and then we have to put omega equal to 0. So when I differentiate it, I will get x of t, and here this is minus jt and e to the power minus j omega t dt. Now substitute omega equal to 0. So dx of omega upon d omega at omega equal to 0 is minus infinity to infinity. It is e to the power minus t to the power 4 and cos t, that is our x of t, and minus j t, and this omega equal to 0. So this is dt. So you can see that this particular term e to the power minus t to the power 4 and cos t is an even function. It is an even function. Okay, and t is an odd function. T is an odd function. So we know that the multiplication of even with the odd signal will give you the odd signal. So that means this dx of omega divided by d omega at omega equal to 0 will become integration from minus infinite to infinite of an odd function. So integration of an odd function will always be equal to 0 from minus infinite to infinite. Okay, if you integrate the odd function for the entire range minus infinite to infinite, then this will be 0. So the right answer for this question will be 0. Now the next question. The input x of t and the output y of t of a signal of a system are related as y of t is equal to e to the power minus t integration from minus infinity to t e to the power tau x of tau d tau. Then the system is non-linear, linear, and time invariant. Linear but not time invariant, etc., and non-causal. Okay, so because this is the integration, so it is directly, it follows the integration follows the superposition law. Law of superposition, hence it is linear. Okay, so these two options, this option can be incorrect. So this will be linear for sure. Now we have to check whether it is a time invariant or not. So we have yt equal to e to the power minus t integration minus infinity to t e to the power tau x of tau d tau. Now let's delay this signal t minus t naught. So e to the power minus t minus t naught minus infinity t minus t naught e to the power tau x tau d tau. You will get this. Okay, put it equation number 1. Now let's delay the input. So y of t is equal to integration minus t minus infinity to t e to the power tau x of tau minus t naught and d tau. Now here we have to assume let tau minus t naught is equal to k. So d tau is equal to dk. What about the limit? And when the tau is equal to minus infinity, k is equal to minus infinity. When the tau is equal to t and the k is equal to t minus t naught. So this will become y of t e to the power minus e to the power minus t is there, no? Okay. So e to the power minus t integration minus infinity to t minus t naught e to the power tau. Tau is replaced by k plus t naught. Okay, and this tau is replaced by k plus t naught and x of k and d k. So when we rearrange it, we will get e to the power minus t e to the power plus t naught and integration minus infinity t minus t naught e to the power k x of k d k. So e to the power, this term we can write minus t naught we can write, and integration minus infinity t minus t naught e to the power k x of k d k. This is our equation number 2. So here you can see that this yt and t minus t naught are same. So yt is equal to y t minus t naught. That means it is time invariant because it is not changing with time. Even if I delay, it is not changing with time. So it is linear and time invariant. Option B will be the right answer for this question. Okay, simple. Now next question is, consider the discrete time system T1 and T2 defined as follows. T1 x of n, x0, 1, 2 and so on up to xn, and transformation of x of n, x0 plus 1 by 2 x of 1 and so on up to 1 by 2 power n xn. Which one of the following statement is true? T1 and T2 are Bibo stable, T1 and T2 are not Bibo stable, T1 is Bibo stable but T2 is not stable, T1 is not stable and T2 is stable. Okay, so here to check whether the system is stable or not, what we have to do? We have to give the bounded input. To check Bibo is stable, bounded input should be given. Bounded input results bounded output. Then we can say that it is a Bibo is stable. Okay. Then here, suppose we give Bibo input, bounded input. Let's give bounded input. Let's assume that it is summation x of n mod of summation of x of n is less than equal to n for all the values of n. For all the values of n. So here we have t1 x of n, x of 0, x of 1, x of 2, every value is m. So x of 0 plus x of 1 and so on up to n. All the values are, we have assumed that it is equal to or less 1. So maximum value is m. So it is, so how many terms are there? M plus 1 terms are there. So m plus 1 will be the input. So we are giving the bounded input, m plus 1 into xn will come. So you can see that as we increase the m, it is increasing non-linearly. So non-linearity means it is continuously increasing like this. I want to say that it will be continuously increasing. When you put n equal to 0, it will be having some value, then n equal to 1, n equal to 2. So as you go on increasing, it will be reaching up to the infinity. So it is not bounded output. So it is not a bounded output. Not a bounded output. Okay, now for the second one, T2x of n, that is equal to x of 0 plus 1 by 2 x of 1 and so on, 1 by 2 to the power n x of n. So if I give input m, then it is 1 by 2 m and so on plus 1 by 2 to the power n into m. So it will be m is common. So 1 plus 1 by 2 plus 1 by 2 square and so on up to 1 by 2 to the power n. So it is m 1 minus 1 by 2 to the power n divided by, it is up to n, na? 1 by 2. Okay, is it clear? Just check once. So now you can understand that if we are giving input in this way, what we are getting in the output, which is a finite duration now. Because if I suppose increase the number of terms to infinite, that is number of terms are infinite, then there is no problem because it will be giving you a finite output. Okay, because this series is convergent geometric series. Okay, this series is convergent geometric series. Okay, so when n tends to infinity, you will get the finite output. So that is, it is a Bibo stable. So the second one is Bibo stable and the first one is not a Bibo stable. Wait, here it is n plus 1. No? Total how many terms are there? N plus 1 terms are there. So n plus 1 into n. N plus 1 into n. So output is growing linearly with n. Here the output is growing linearly with n. With n. Okay, because how many terms are there? N plus 1 terms are there. So n plus 1 into m will be there. No? Okay. So now what will be the right answer? T1 is unstable and T2 is stable. So answer is option D. T1 is not stable, but T2 is stable. Now the next question. If the Z transform of a finite duration discrete time signal x of n is x of z, then the Z transform of the signal y of n is equal to x of 2n is. Y of z is equal to x of z square 1 by 2 x to the power z minus 1 by 2 plus x to the power minus z minus 1 by 2 or 1 by 2 x to the power z 1 by 2 plus x to the power x of minus z to the power 1 by 2 and x z square plus x minus z square divided by 2. So this is actually direct property, but let's understand it by one example. Let's assume that x of n is 1, minus 1, okay, any value you can choose, 2 and minus 2, okay, any value. Now if I suppose draw x of 2n, then I'm assuming that this is 0, then this will be 1 and 2. X of 2n will be 1 and 2 every second sample, okay, so every second sample. So if I take suppose the z transform of this, let us say this is y of z, z transform of x of 2n, then according to the formula summation over n and x of 2n into z to the power minus n. When we put n 0, so we will get first value, so which is 1. So 1 into z to the power minus 0 plus 2 into z to the power minus 1. So we expect 1 plus 2z inverse. Okay. This I am assuming suppose yn, then you can write in this way. So maybe you will not get confused with this. So let's assume z transform of yn, and this is yn. Okay. Now you will get this. If you suppose take the decimation and then you will take the z transform, you are expecting the output as 1 plus 2z inverse for this particular segment. Now we have to verify this property. So what you can do, which option can be correct here? So let's calculate y of x of z directly. Okay, let's calculate x of z directly from here. So what will be the x of z? According to the same formula, this is 1 plus minus 1 to the power z to the power minus 1 plus 2 into z to the power minus 2 plus minus 2 into z to the power minus 3, because this is n equal to 0, 1, 2 and 3. Now if I suppose calculate x of z to the power 1 by 2, then it is 1 minus z to the power minus 1 by 2 plus z to the power minus 1 minus 2z to the power minus 3 by 2. If I suppose calculate x to the power minus 1 by 2, z to the power minus 1 by 2, then it is 1 minus 1 by 2, okay, minus z. I want to calculate x to the power minus z to the power 1 by 2. That means z is replaced by minus z. So if the z is replaced by minus z, then it will be plus z to the power minus 1 by 2. And this is even function, so it is z to the power minus 1. And this is again plus 2z to the power minus 3 by 2. Now if I divide, if you can see this, if I add these two equations, that is x to the power z to the power 1 by 2 plus x to the power minus z to the power 1 by 2, then I will get 2. This will get cancelled, this will get cancelled, and we will get 4z inverse. So if I divide it by 2 both the side, then I will get 1 plus 2z inverse. This is equation number 2. So here you can see that 1 plus 2z inverse we have got in the equation number 1, and here also in the equation number 2. So that means this, taking the z transform of y of n, or you can say the taking the z transform of x of 2n is equivalent to x z to the power 1 by 2 plus x minus z to the power 1 by 2. So if I calculate the y of z, it is equivalent to this. Okay, y of z is equivalent to x of z to the power 1 by 2 plus x to the power x of minus z to the power 1 by 2 divided by 2. So this can be done by the example. So remember that we cannot directly apply the property of z transform here, because in the decimation the property of scaling fails. No? Remember this point, that in the scaling you cannot apply here like x of n by m is having the z transform x of z to the power m. Okay, this is the z transform, but you cannot apply here because here the process is decimation, so the samples are missed. So if the samples are missed, then you cannot apply this property directly In that case, you have to remember that whenever there is a decimation, the scaling property work like this. This is 1 upon m and minus z to the power 1 by m. M is the factor here 1 by 2. Okay. M is 1 by 2 here. No? M is 1 by 2. So the property is z to the power m, z to the power m plus minus z to the power m of x. Of x. Okay, this is the property whenever the decimation happens. Now the last question for this session is, if the energy of a continuous time signal x of t is E, the energy of the signal 2x 2t minus 1 is Ce, then the value of Ce is. So we should know that suppose the signal x of t is having the energy E, then Ax t will have the energy A square E, and x t by alpha is having the energy E upon alpha. Okay. So if I combine these two property, I can say that the energy of this, which is Ce, is nothing but the 2 square into E upon alpha. Alpha is scaling factor, that is 2. So this E and E will get cancelled and we will get C is equal to 2. So the energy is going to change by the factor of A square upon alpha into E. Okay, the scaling factor and the amplitude scaling factor only changes the energy of the signal with the time shifting. This is also the time shifting by 1. Time shifting does not affect the energy of the signal. So it is A square upon alpha into E, and when we compare it, we get this value of C is 2. So the right answer for this is 2. Very easy question, property based. Okay. So this is all about the session of the questions of the signals and system in this session, and you can also contact in this number to get the full course of the signals and system, and also the GATE complete course for 2025 and 2026. Thank you, and don't forget to subscribe this channel.